In Module 8A, we are going to talk about special segments in a triangle. And in these first set of notes, we are just going to describe what those special segment names are and how to determine what our main characteristics are going to be for those segments. The first one we're going to talk about is the medians. And a median of a triangle is a segment whose endpoints are a vertex of a triangle and the midpoint of the opposite side. Every triangle has three medians in it, and the intersection of where those three medians cross each other, that point is called the centroid. So the biggest part you want to remember is that it connects your vertex to the midpoint on the opposite side. Onto the midsegment. A midsegment of a triangle is a segment that connects the midpoints of two sides of the triangle together. So every triangle has three midsegments. In this triangle off to the right, if I wanted point D to be the midpoint, that would mean that AD and DB are congruent to each other. If point E is the midpoint, that means that BE and EC are congruent. And if point F is a midpoint, that means that AF and FC are also a midpoint of that side. So if we connect those together, the midsegments of this triangle are going to be DE, EF, and DF. To go along with that, we have a midsegment theorem, and that means that the segment connecting the midpoints of two sides of a triangle is parallel to the third side. If you look up at my picture up above, that means that side or segment DE, so our midsegment, is going to be parallel to the third side, and that would be AC. The length of it is going to be half as long as the third side as well. So that means if DE is 10, that means that AC would be 20. What I want to make sure you write down on your paper is that if we double the midsegment, that will equal our parallel side. That's going to be the easiest way we can set up our equations to find the missing side, depending on which piece we are given to. Next is our angle bisector. So an angle bisector divides an angle into two congruent angles. A point on our angle bisector, so that'd be our point D down here, if it bisects my angle, that means those two angles are congruent. So my point D is equidistant from both sides of the angle. So that means this distance right here, so dx and dy, are going to be congruent to each other. When we are following along right here, so if we have BD bisects our angle ABC, I can put my little marks in there that those are congruent. I see point D is on that line, so on that angle bisector, and that means it is going to be the same distance from each of the sides of my angle. And we mentioned before that if we have the length of XD, that will equal the length from Y to D. Perpendicular bisectors is when we have a perpendicular bisector of a triangle is a line or segment that divides a side of your triangle into two congruent segments. The perpendicular bisector forms a right angle with the side of the triangle that it bisects. So we can see that point E is where it bisects our side AD, and so it cuts it in half, plus it is 90 degrees. So in our figure, BE is our perpendicular bisector of segment AD, so AE is going to be congruent to DE, and our angle DEB, so DEB, where we connect our three letters together, is going to equal 90 degrees. Our last special segment is called an altitude, and an altitude is a segment that extends from a vertex of a triangle to the opposite side so that it is perpendicular to the opposite side. And one thing you want to remember about an altitude is that the altitude segment could be inside our triangle, on the triangle, or outside of the triangle. In our figure off to the side, we have XU, so segment XU is right here. There is one altitude. We also have another altitude is WZ. And thirdly, we have VY. And all three of those are altitudes because it connects the vertex to the opposite side, and where it crosses the opposite side is 90 degrees. So our altitudes are also known as the height of a triangle. So whenever you need to use the equation of our area of a triangle, we would use 1/2 times base times the height. The height itself is really the altitude. And those would be this type of questions that we could ask you also about the altitude.